Hello, this is the second video of the Hyperbolic Function Series 2 on inverse hyperbolic functions for OCR Pure Core Further Mathematics, and it covers differentiating the inverse hyperbolic functions. Let's start by differentiating sin to the minus 1 of x. If y equals sin to the minus 1 of x, then we can take the sin of both sides and say that sin y equals x. We then use implicit differentiation, which we'll have done in A-level maths. So differentiating that would give us cos y dy by dx equals 1. Rearranging would give us dy by dx equals 1 over cos y, which, using the identity here, we can rewrite as being 1 over the plus or minus the square root of 1 plus sin squared y. Therefore we can write this as being 1 over the square root of 1 plus x squared. Although we had here that dy by dx could have been the positive or the negative root there, in effect we only choose the positive root. By consideration of the blue curve y equals the inverse of sin x, r sin x, then we can see that that gradient of that blue curve, you always have that dy by dx is greater than or equal to 0. Hence we will only take the positive root. An alternative method to finding the derivative of sin to the minus 1 of x is to use the logarithmic expression for sin to the minus 1 of x, as given here and which we covered in the previous video. Therefore you would substitute that in, and using the chain rule really carefully, you should try and do this to yourselves to get the same answer as the previous method, or you could look it up in the textbook. Here we have differentiated cos to the minus 1 of x using exactly the same method. However, note that the sign in the answer is different. It is negative, whereas dy by dx of sin to the minus 1 x was 1 over the square root of x squared plus 1. Note again that the gradient of that blue curve y equals arc cos x is again always positive. And that is why we have only taken the positive square root of the two options that the algebra might indicate. If we were to differentiate sin to the minus 1 of 4x, let's write that out. So d by dx sin to the minus 1, and I'm going to put the 4x in brackets because that will remind me to use the chain rule carefully, because it's really easy to forget that 4. So that would give me, using this result we had earlier, 1 plus 4x squared, and then I would need to multiply by that factor of 4. This gives me then 4 over square root of 1 plus 16x squared. So remembering then, when you have a kx, then you must remember to use the chain rule carefully and multiply again by that k. So these derivatives are in the OCR formula booklet, but they're under the integration table. They are particularly useful to extend the range of functions that we can integrate. An exercise you may wish to try is to prove the result for the derivative of tan to the minus 1 of x being 1 over 1 minus x squared. In the next video, we will look at integration using inverse hyperbolic functions.